Hello everyone, this is for pre-calculus. It's on reviewing some exponent and radical rules. First in looking at this, I'm not exactly sure why I typed this one the same. I think they're identical. Yeah, so how about I'll just ignore this one and start here. The idea when you're adding or subtracting, you have to have like terms. What makes like terms is that they have the same base with the same exponent when you're adding or subtracting. These have the same base but different exponents, so you can't touch it. There's nothing you can do. Whereas this one has the same base with the same exponent, so you just add the coefficients. When you're multiplying, you just multiply the coefficients, so you'd have 10, and then that's saying x cubed times x squared, which is x times x times x times x times x, which is x to the fifth. So when you're multiplying, you add your exponents. When you're dividing, one way to see this, and then these will cancel. So you have one x left on the bottom. You had 3 on the bottom and 2 on the top. Now you only have 1 on the bottom, so you subtract your exponents. You don't have to write it out like this. I'm just illustrating the point that when you're dividing, it's subtraction. Okay? I'm going to sneeze. Hold on. Excuse me. You're dividing, and you subtract your exponents. Turns out there's more on top, so it stays on top. When you have a negative number squared or cubed or anything like that, let's try this one. Would you guys agree that's negative 1 times x squared? These are identical. So the negative isn't being squared. Whereas this one is negative 3 times negative 3. That becomes 9, where this one becomes negative 9. So when you don't have a parenthesis on a negative number being squared, the negative doesn't know about the square. All right? Here, anything that has a negative exponent moves. The 5 doesn't have a negative exponent, so it stays put. This has a negative exponent, so it goes downstairs. If it was downstairs with a negative exponent, it would go upstairs, like 3 over x to the negative 5. This has a negative exponent, so it's going to go upstairs, but the 3 stays put because it has a positive exponent. Okay. Things with negative exponents move. Things with positive exponents don't. So that would be your answer. So likewise, I'm just going to go through this. I'm going to go through the top. So x squared comes down, y to the 6 stays up, z cubed goes down, going to the bottom. I got an x to the 4th, a y cubed comes up, and a z to the 4th comes up. Now I can start simplifying stuff. So the top is going to be y to the 9th, z to the 4th, over the bottom, x to the 6th, z cubed, and then you finish it off by doing the subtraction here. So you can have y to the 9th, z, over x to the 6th. And you're done. If you want to put a 1 there, you can, but you don't have to. Okay, what we talked about before is that's going to be the square root of negative 9, because the negative doesn't know it's being squared. You can't cancel these if what's inside is negative. You first have to deal with that negative, so it comes out as I. Now the square root of 9 is 3, so your answer is 3i. Same thing here. I can't cancel this if what's going to be in there is negative, because when you do this out the long way, you get 3. Whereas if you do a shortcut, you get negative 3, which is not right. You have to guarantee what comes out of an even root is positive. So this is not correct. 3 is correct for this. All right? Fractional exponents, this is exactly the same thing as the square root of 2. This would be the cube root of 2. This would be the 4th root of 2. This would be the 4th root of 2 cubed. So the top is the power, the bottom is the root. These all have a 4th root. So that's 5 to the 1st, x cubed, y to the negative 5. So in other words, this would be a great big 4th root, meaning there's going to be a fraction in it, 5y y cubed, whoops, x cubed, I apologize, over y to the fifth. Okay, so that's all. That's just inside the fourth root. Just makes a fraction. Getting you guys to translate back into fractional form, this would be x to the 2/3. This would be x to the 2/3, y to the 5/3, and z to the 8/3. Okay? Reducing radicals. If the power matches the root, something pops out. Here the power is matching the root, so in effect they're canceling. So I get this. If you want to think of it as writing it with, like we did up here with these exponents like this would be x to the 2/2, which is x to the first, which is your answer. I'm not looking for you to translate this into x to the 3/2. That's not where I'm looking for you to go. That is correct. But what I'm looking for you to do is to think of it as a square root of x squared times x to the first. That's x cubed. The power is matching the root, so this is going to pop out. This has to stay behind. So x squared of x. There is a shortcut. I'm just doing it this way to help you to illustrate the pattern that I'm using. I'm having the powers match the root, so that's going to pop out as x. That's going to pop out as x, so I get x squared. Now the shortcut for these is 2 divides into 3 once with a remainder of 1. 2 divides into 4 twice with nothing left over, so there's no root. 2 goes into 5 twice with 1 left over. 2 divides into 6 evenly, so it's just x cubed. 2 divides into 7 3 times with 1 left over. 2 divides into 8 4 times, so it's x to the 4th. 3 goes into 3 once, so it's just x. 3 goes into 4 once, with 1 left over. 3 goes into 5 once, with 2 left over. 3 goes into 6 twice. 3 goes into 7 twice, with 1 left over. 3 goes into 8 twice, with 2 left over. Whoops, I didn't write a 3. I don't know. Whoa, that's a huge one. 4 goes into 4 once. 4 goes into 5 once, with 1 left over. 4 goes into 6 once, with 2 left over. 4 goes into 7 once, with 3 left over. And 4 goes into 8 twice. Right? Doing a little bit of prime factoring. So 2 goes into 8 4 times, goes into 2 and 2. So you get 2 cubed is 8. 2 and 6, 2 and 3. So it's 2 squared times 3 to the first. 24 is 2 and 12, 2 and 6, 2 and 3. So 2 cubed times 3 to the first. 2 and 16, 2 and 8, 2 and 4, 2 and 2. 1, 2, 3, 4, 5, so 2 to the 5th. 40, 2 and 20, 2 and 10, 2 and 5, so 2 cubed times 5, 2 and 24, 2 and 12, 2 and 6, 2 and 3, 1, 2, 3, 4, so 2 to the 4th times 3. So these are those numbers prime factored. So if you're square rooting 2 cubed, 2 goes into 3 once with 1 left over. If you're cube rooting 2 cubed, you just get 2. If you're fourth rooting 2 cubed, nothing happens because the exponent's not big enough. So square rooting 12 would be 2 squared times 3. 2 squared pops out as 2. Squared is a 3. Cube rooting 2 squared times 3. So cube rooting 12, nothing's going to happen. Fourth rooting 12, none of the exponents are big enough, so nothing's going to happen. Square rooting 24. square rooting this. If you need to put the 2 there to help you see it, great. 2 goes into 3 once, with 2 left over. So 2 square roots of 6. Cube rooting. 2 cubed times 3 to the first. So that would be 2 cube roots of 3. Oops. Fourth rooting it, nothing's going to happen because none of the exponents are big enough. Square root of 2 to the 5th is going to be 2 squared square root of 2, or 4 square roots of 2. Cube rooting 2 to the 5th is going to be 2 cube roots of 2 squared, or 4, whichever way you want to write it. And fourth rooting 2 to the 5th is 2 fourth roots of 2. So you get the idea, you get the hang of it. I don't know if you guys need me to keep going. Square root of 40 is 2 cubed times 5. 2 goes into 3 once, with 2 and a 5 left over, so 2 square roots of 10. Cube rooting it, the 2 will pop out, so 2 cube roots of 5, and the fourth root, nothing will happen. Okay? I don't know if you need me to do 48, and just in the interest of time, it's not that I'm being lazy, it's just, I'm trying to shorten the video. So when you're doing this with the variables, 4 goes into 4 once, 4 goes into 8 twice. 4 goes into this, so it's w x squared y with a fourth root of y left over. So w, and then x squared with an x left over. 4 goes into 14, what would that be, 3 times with 2 left over? All right. 24, you have to prime factor it. 24 was 2 cubed times 3, x to the 6th, y to the 7th. 2 goes into 3 once, with 1 left over. The 3 has to stay put. 2 goes into 6 3 times. 2 goes into 7 3 times, with 1 left over. So your final answer would be 2x cubed y cubed square root of 6y. It's square root, so I don't need to put the root there. It's optional. Okay? So I think that's all I need to review. Kind of a crash course. Hope it worked well.